Hello and welcome to another Mindbreeze tutorial. Today we will look at how to configure the Microsoft File Connector, including a short introduction, the required preconditions, and the index configuration. We will also look at the Active Directory-based authentication as well as LDAP and how to analyze crawled documents and crawl runs in App Telemetry. Our plan today is to index our Samba share with ACLs taken from our LDAP server. It is not recommended to index any file share without ACLs in place, so an AD or LDAP server is recommended from the get-go. To start with, let's log in to the Mindbreeze appliance and head to the configuration. First, we will configure the credentials we need for our crawler. To do this, let's head to the Network tab and add a new credential. We will scroll to the bottom of the Network tab and click on Add Credential with the type Username Password. We will give it an appropriate name and then add our crawling username, domain, and password. Adding a credential object is advantageous because the credentials added are encrypted and admin users who configure services using these credentials, such as crawlers or caches, do not need to know the sensitive passwords themselves. They can simply select the configured credential from a drop-down menu. The next task is to add an endpoint for our file share. This maps the configured credential to the file share URL. To do this, we will click on Add Endpoint, add the root URL of the file share, and then select our credential from the drop-down menu. Finally, we will scroll up and configure an LDAP server. We can add multiple servers here if we wish, and unless specifically disabled, Mindbreeze will perform automatic LDAP server discovery. Now that we have finished all of the networking prerequisites, let's take a closer look at the LDAP cache. So, why do we need to use caches in the first place? Quite simply, they help to reduce the amount of load on the target systems in a controllable way. Calls are not made directly to an LDAP server to resolve users and groups, rather to a cache hosted locally on the Mindbreeze appliance. This increases speed and efficiency of crawling and searching, as well as reducing load on the LDAP server. To configure the LDAP cache, we need to add it as a service. Services can be found at the bottom of the Indices tab. Let's configure an LDAP cache by adding a new caching LDAP principal resolution service. Let's give the cache an appropriate name and then add the LDAP server hostname. Now, let's add the credential we configured previously using the drop-down menu. If we now scroll down to the cache settings, we need to add the database directory path. This is the location on the file system on the appliance where the cache will be saved. Please ensure that the configured location is its own unique folder. Under this, we can configure the cache update interval. This is how often this service will try and update the cache. If this is set to any value below 0, automatic cache updates are disabled. Finally, at the very bottom, we can configure the web service port on which this LDAP service will run. We must ensure that this is always a free port unused by any other service. We will change this to 23903 so that it is unique. Now, let's save and restart and take a look at how we can debug and more precisely control our caches via the included API. You can access the API endpoint of any cache via your appliance at your appliance URL port 8443/cache/port number of your cache and then /control. To send requests to this endpoint, we need to send the action parameter along with the appropriate value. For example, we can force a cache update with action equals update cache, or we can download a specific principal using the cache check principles, and then supplying the individual ID parameter along with a username. Let's take a look at this now with the user David Porter. Here, we can see the full principal stored in our LDAP cache for this user, directly in the browser in a readable format. Now that we've had a look at the LDAP principal cache in detail, Let's look at how we can configure a file system index and crawler, which will then use this cache. Firstly, let's add a new index with a Microsoft File connector, and then give our index an appropriate name and scroll down to the Data Sources section. The Microsoft File connector automatically handles the category instance settings, so we do not need to configure it here as we do in other crawlers. The Ignore Category Instance option should be used if we have multiple separate file system crawler instances defined within one index, but which should appear as one data source. For example, the same source name on the front end. Without this option, enabled filtering would behave unpredictably. We can leave it unchecked for our use case as we only have one file system crawler on this index. Next, we will add the data source name. This is how the data source will be named on the front end. Then, we should select our caching principal resolution service. This will be the LDAP principal cache service we have just configured. The authorization service gives us an extra option to add an authorization plugin to allow for authorizations via additional services such as databases. We can ignore the authorization service option for our use case today, as LDAP is sufficient for us. After we have named the crawler, we can start configuring the file system specific parameters. Firstly, we need to add the file share root directories which we want to crawl. If desired, we can add multiple start points here for our crawler. The domain name of our file system, dc.academy.fabersoft.com, should be the same as we have configured in our endpoint. We need to make sure that our root directories follow the UNC path format. Next, we will leave the Supports SMB2 option enabled, as this will allow the crawler to use Samba version 2 for crawling. This is the recommended approach. It is best practice to leave the SMB packet signing enabled, as this allows the SMB packets to be signed and verified during transmission. The SMB client read timeout defines the timeout in seconds when attempting to connect to the file share. We will leave this as the standard 300 seconds for now. The number of threads defines the number of crawler threads which will be crawling the target file share. The more threads we have will lead to higher speeds during crawling, but will also cause more load on the file share. Care must be taken when crawling older servers or self-scaling cloud services. The default of 5 should be fine for most use cases. The batch size is the number of documents queued within the crawler before being sent to the index. If we increase the crawling threads, it is best for efficiency if we also increase the batch size in the same ratio. The document size limit simply defines the maximum size a file can be for it to be crawled. Documents larger than this size will be ignored by the crawler. Using the includes and excludes field, we can input regular expressions to match files and directories which should be included or excluded in the crawl. In a similar way, we can use the include patterns and exclude patterns text boxes to input multiple regular expression rules separated by line, which accept a wider variety of syntaxes, including, for example, the prefix regex ignore case. If we do not wish to be able to view folders as search results, we can exclude these using the Exclude Directories button. Please note that when this option is enabled, all folders will nevertheless be traversed by the crawler for file discovery, but none will be sent to the index. With the Full Traversal Interval option, we can set up how often the crawler should perform a full delta check of the file system. If this setting is not checked, Mindbreeze checks each folder and each file individually for changes with each delta crawl run. This can be a very time-expensive procedure. For very large installations, it is recommended to set this full traversal interval. If this option is used, only folders are checked for changes in a normal delta crawl run, and if changes are detected in the folder, then the files contained within the folder will be checked. A full traversal, where both files and folders are checked, would then only occur based on the configured time interval, rather than every crawl run. We can use the Remove Deleted Documents from Index option to tell the crawler to remove documents from the index which were no longer found after a full traversal crawl run. For example, if we updated the include or exclude patterns. For crawling large files, we can use the content location optimization combined with mounting the file system on the appliance to increase crawl speed and efficiency. Now that we've looked through all of the source settings, let's move on to the access rights settings. With the ACL security level option, we can control whether ACLs are inherited from the directory, the file share, or if this option is disabled completely. Out of the box, this is configured to be the directory level. To resolve the domain users or domain groups of an ACL that is a member of a local group, access to LSA, Local Security Authority, and SAM, Service Account Manager, using the RPC SMB protocol is required. It is therefore necessary that the crawler service user has one of the following access authorizations to LSA and SAM: maximum allowed, generic all, generic execute, generic read, or read control. We can configure this level with the desired access for LSA and SAM here. To correctly assign the file permissions for different domains, we must select the Resolve All Domains option. To use this, we must then configure the LDAP servers for these domains in the section directly below. The Resolve All Domains option, as well as LSA and SAM, is mostly used in cases of ADFS. After we have finished configuring our access rights, we can set up the crawling user credentials in the Credentials section. Here, we can add the username, domain, and password of our crawling user. Next, we have the Extensions section. This is an advanced configuration section for extending the functionality of the file system crawler using the indexFileLister.spi.jar add-on. With this interface, we can add custom functionality to the connector so that it can, for example, crawl from an index file or append additional metadata from file. If you think you need this functionality, please contact us directly. Now, we can take a look at the final section of the configuration. The Always Update Files Matching regex option allows us to define documents which will always be sent to the filter service, regardless of whether they were changed or not. Enable heap dump on out of memory allows us to log a heap dump if the crawler failed due to an out of memory error. The Max retry duration by filter connection problems option allows us to set the maximum amount of time the crawler is allowed to retry sending a document to the filter service during connection issues. The retry interval during repository connection problems allows us to define the amount of time the crawler waits before retrying to connect to the data source when there are connection issues, and the max retry duration during repository connection problems option allows us to set the maximum amount of time the crawler is allowed to attempt to reconnect to the data source during connection issues. Now that we have fully configured our crawler, let's scroll back to the top and save and restart. Because of our configured rules, we currently cannot save this configuration as it is attached to a client service which has no authentication method enabled. We can stop this error by enabling the Unrestricted Public Access option. If we keep the Enforce ACL Evaluation option enabled, we will be able to save, but won't be able to view any documents in the search client without first logging in as an authenticated user. Mindbreeze will then evaluate the ACLs against this authenticated user. Now, let's have a look at our crawl run in App Telemetry. Tip: for more information about how to use App Telemetry, please have a look at our App Telemetry tutorial video. First, let's navigate to Reporting, Telemetry Details, and then open the crawler logs, and then View Telemetry Data. If we organize the logs by start time, we can see our most recent logs at the top. Now, we can right-click on the Operations column and add a new filter to view only logs where the operation contains crawled documents. This will show us all logs which occurred during a crawl run. Next up, we can right-click on the Category column and add a new filter to view only logs where category contains Microsoft file. This will constrain our logs further to this specific category. If we select one of these rows in our log pool of crawled documents, we can then view the associated requests tab in the pane below. This shows us all services used during the ingestion of this document into Mindbreeze during the indexing process, including the filter service, the index service, and the crawler service. This is incredibly handy, as we are now able to view all of these services and their logs in the context of one document, and we can view the status of this document at each stage in the pipeline, all in one place. Now, let's take a look at a whole crawl run in App Telemetry. If we again open App Telemetry and then navigate to Applications, Crawler Service, View Telemetry Details, we can see the same data as before. Now, let's sort by time and add a filter on the Operations column, so that now it will only show us of operations of type crawl run. Again, we will make sure we also filter the category to see only Microsoft file results. Let's click on one of these results now and take a look at the details which appear below. Here, we can see in-depth information about this specific crawl run, including timeline data, crawl run statistics, and more. Thank you for watching this Microsoft File Connector tutorial video. Further in-depth areas we did not cover in this video, which you might want to look at in more detail, include PDF previews, deep index analytics, and translations with the category descriptor.